Hi guys, it's the Sciencebarbie. Today we're going to talk about eigenvalues and eigenvectors. Now here we have a 2 by 2 matrix A. It says 2 rows and 2 columns with the entries -2, -5, 1 and 4. And now let's first start with finding the eigenvalues. So step 1 is finding the eigenvalues. Let's do this in a step-by-step manner so it's easy for you to follow and to exercise it. Okay, how do we find the eigenvalues of a matrix? Well, it works like this, that first of all we calculate the determinant of the matrix A minus lambda times the identity matrix and set this to 0. Now let's first do this A minus lambda times I. Okay, how does this look like? A is -2 and 1, -5 and 4, minus lambda times the identity matrix. That's 1, 0, 0, 1, which now is, let's start here, -2 minus lambda times 1 is lambda. Second entry here, -5 minus 0 is -5. Here we have 1 minus 0 is 1. And here we have 4 minus lambda times 1 is 4 minus lambda. Okay, now let's calculate the determinant of this. Let's make it like this. If we have these two straight lines here, it means it's the determinant, and we just apply the rule of Surrey, which is -2 minus lambda times 4 minus lambda minus, now the other diagonal, -5 times 1. Okay, let's continue here. Okay, -2 times 4 is -8, -2 times minus lambda is +2 lambda, minus lambda times 4 is -4 lambda, minus and minus is plus lambda squared. Now we are here, minus and minus is +5. Now let's sort it descendingly according to the exponents of lambda. We start with lambda squared, then we have 2 lambda minus 4 lambda is -2 lambda, and we have -8 plus 5 equals -3. And because this needs to be set to 0, that's what we do. Okay, now how do we solve this? This is a quadratic equation. We take the formula. What's the formula looking like? It's lambda 1, 2 equals minus p half plus minus the square root of p squared 4 minus q, and here we take the square root. Okay, now let's just do this. Now let's say it's okay, it's lambda 1, 2 equals minus and minus, here is plus, 2 by 2 is 1, plus -2 to the power of 2 is 4, by 4 is 1, minus and minus is plus, and we have 3 here, that's our q. Here we take the square root from the formula here. In Austria we call it the midnight formula, because students are supposed to remember it when the professor calls at midnight. Okay, now it's 1 plus -1 plus 3 is 4, the square root is 2. Now we have two solutions for lambda. Lambda 1 is 1 minus 2 is -1, and 1 plus 2 is 3. And now we already have the two eigenvalues of the given matrix. Nice, isn't it? Okay, now the next step is to find the eigenvectors. Now step 2, eigenvectors. Again, we're going to apply a certain formula, then just follow it through. Now how we're going to find, the eigenvectors, it's just we solve again an equation. It's A, the matrix A, minus the eigenvalue times the identity matrix times the eigenvector V, call it V, and this is 0. Now let's start with the first eigenvector, lambda 1 equals minus 1. Here we start, and then we're going to see it's very similar also for the second eigenvector. Okay, now let's say it's minus 1. Okay, now A, maybe we write it down again, then it's easier. Minus 2, minus 5, 1, and 4, minus lambda times I. Lambda is minus 1, minus and minus is plus, okay? And the identity matrix is 1, 0, 0, 1. Now we just add it all up. Minus 1 plus 1 is minus 1, minus 5 plus 0 is minus 5, 1 plus 0 equals 1, and 4 plus 1 equals 5. Okay? Then we need to multiply with the eigenvector. Every vector has two coordinates, x and y, if it's a two-dimensional vector, and this is set to the 0 vector. Okay, now we know from matrix multiplication we need to solve two equations here, so we just multiply. Minus 1 times x is minus x, plus minus 5 times y, minus 5y, equals 0. And we don't really need the second equation. Why? Because we see the second row is linearly dependent from the first row. If we multiply the first row by minus 1, we get the second row. So we stay here with the first row, and we just do some equivalence transformations to get x. Now we put 5y to the right side, and we get minus x equals 5y, and again we want to have x, so let's multiply it by minus 1, and we get x equals minus 5y. That's already a nice result, because what we can do now is we can choose any value for y. So we choose y equals 1. I mean, that's just the same. You could choose 0 or 10 or whatever. Just 1 is nice here, because then you don't get the trivial solution. So if we have y equals 1, we have x equals minus 5. And now our first eigenvector, let's write it here, v1 for lambda 1 equals, here x is minus 5 and y is 1. And this is our first eigenvector. Awesome. Now let's move on to the second eigenvector. For lambda 2 equals 3, we just do the same. We start again with matrix A. It's minus 2, minus 5, 1, and 4. Minus lambda times the identity matrix. Minus lambda is 3, so it's 3, 0, 0, 3. Now, if we calculate this, minus 2 minus 3 equals minus 5. Here, minus 5. Here it's 1. And 4 minus 3 equals 1. times again the two coordinates of a two-dimensional eigenvector supposed to be set to the 0 vector. Again, we just multiply the first row here with the first column. So we get minus 5x minus 5y equals 0. Again, we want the transformations to get x, so it's minus 5x equals 5y. We multiply by minus 1, so we get, or let's say we divide by minus 5, okay? We divide by minus 5, that's the transformation we perform here on both sides of the equation. Now we get x equals minus y. Okay, again, no need to do the same for the second row because we see it's linearly dependent on the first row. Now again, we choose y to be 1, okay, then x equals minus 1. Now we got the two values of the second eigenvector here, and therefore our second eigenvector v2 equals minus 1, and 1, and that's the second eigenvector. Okay, and what can we imagine with these eigenvectors? Probably make just a sketch here. Okay, if we have here a coordinate system, I hope you can see that. Okay. Let's say that's the x-axis and the y-axis. Now here we have 0. Let's say this is 1. We can even make it a bit bigger. Do we have 5 centimeters? Yes, so that's 0.5. And here we got 1, minus 1, and minus 1. I think you could see it well. Now let's first start with here the first eigenvector. It has the coordinates 1 and 5. Now would be 1 and minus 5. Okay, that's, I can't get it. No, it's minus 5 and 1. Oh, that's fine. It's minus 5 and plus 1. I just misread it. It's this. So it's minus 5 on the x coordinate and plus 1 on the y. Now this looks like this. Okay, that's v1, and the second one has minus 1 and 1. It looks like this. That's v2. Okay, and these two vectors are linearly independent. And what do the eigenvectors mean? They mean that any other vector can be reached with a linear combination of these two vectors. And we see this matrix here. So this matrix does something. It, transposes also the coordinates and makes new coordinates. And whatever this matrix does, these two vectors are untouched. So even if we apply this matrix, the given matrix, to a system of vectors, these two vectors are not going to change their direction nor their length. They're invariant for anything that's been done with matrix A, and that's why they are called the eigenvectors of matrix A. Let's, for example, think this matrix could be a matrix where you rotate something, then these two vectors would not be changed. They would still look the same after applying matrix A to a system of vectors. And I hope you could understand that.
Das war ein Mathematik-Tutorial der Sciencebarbie. Jedes Like und Abo des Kanals freut uns sehr. Für Feedback und Kommentar nutzen Sie die Kommentarfunktion.